Okay, so in this video, I just want to talk about some different forms you might see. So we've got vertex form, we've got standard form, and we've got what we call factored form down here. And these are all just different ways of writing the exact same information, the exact same parabola, but they each kind of have their own little advantages. So what I want to do here is I actually have a parabola graphed here. And what I'm going to do is I'm going to show you how you would write each of these equations or expressions here to graph this parabola. So this parabola can be expressed in vertex form, it can be expressed in standard form, and it can be expressed in factored form. And so we'll write each one out. So vertex form, what's really nice about vertex form, which we'll talk about here in a little bit, is that the vertex, or the very top of the parabola here, since this one opens down, if it opened up, it would be the bottom of the parabola, but this one opens down. So the vertex right here is this top point. This vertex occurs at when x is 3 and when y is 8. So that's really convenient. So right away I can already write x minus 3 squared plus, and then we can put in 8 there. Okay, so those are the coordinates of the vertex, 3 for x and 8 for y. So that's nice about that. You can always put the x coordinate here, the y coordinate there. And then we know this opens down, and in fact, normally parabolas will go over 1, down 1, but this one goes over 1, down 2. And so I can just put in -2 there. And so this right here, if you were going to write y equals -2 x minus 3 squared plus 8, it would graph this parabola right here. Okay, so this is vertex form of this parabola. Standard form is not very obvious why the numbers come up the way they do, but I'm just going to write it out for you. This parabola happens to be -2. Let's write y equals -2 x squared, and then the b value here happens to be +12, and then the c value here happens to be -10. Okay, so if you graphed this right here, it would give you the exact same. It would give you this red parabola here. Standard form is kind of nice because this is actually how most functions just generally appear. So even though vertex form, I think personally, is a little easier to graph, a lot of the functions you're going to see are going to be in this form, where you have something times x squared plus something times x plus just a number over here. Okay, so this right here is the exact same thing as this. And it's funny, if you actually multiplied this out, if you did x minus 3 squared, and then you collected all like terms and everything, this is what you would get. In fact, I actually did that a few minutes ago. I wrote this, and then I just wrote it out like that. Okay, the next form is called factored form. And what's interesting here on all these forms is that you guys will notice how I've color-coded everything. And so notice how the A is red, the H is orange, and the K is yellow. And the A is red, the B is green, and the C is blue. The A here is actually the same for all of these. So if you have a parabola, the A value will always be the same for those. So that's kind of interesting. None of the other values are necessarily the same unless by coincidence. So B is never going to be like the same as P and Q. If it was, I would have written it, but it's not. All right, so on this one, what's really cool about factored form is, I want you to think about this for a sec. If I was going to take a value for x and plug it in, what if I put in P for x? So just think about this with me hypothetically for a second. A times P minus P times P minus Q. Like if the x value I actually put in was P, then what would happen here? That you would get A times 0 times whatever P minus Q is. And it doesn't really matter what A is or what P minus Q is. The fact that we're multiplying by 0 means that this will always return 0 if you plug in P. The same thing happens if you plug in Q. You would get A times x minus P times Q minus Q, which would return 0. So what's helpful about that is if you want to know where the y value is 0, namely this line right here, this is where the y value is 0. The p and the q in this case are the x-intercepts. They're the values that you plug in for x that make y 0. So look at the graph with me. I'll say that again. They're the values for x that when you plug them in, they make the y value 0. Those are called the x-intercepts. What's interesting is if you come over here and look at the graph, when I did this on Desmos, I actually had it highlight these x-intercepts for us. So notice right here that the x-intercept is at 1. This one is at 5. So what's nice about factored form is if you can see the graph and you know what the x-intercepts are, you can just fill those in. So this will be -2 times x minus, and then that first x-intercept there is at 1. The other x-intercept is at 5. And that's it. So these right here, these three equations are all graphing the exact same parabola. Okay, so I want to actually just write out by hand what's nice about each form. All right, so vertex form here is really nice for graphing. And the reason that it's nice for graphing is because we know that the vertex occurs at HK. So we'll just fill those in. I'll just give you a really quick sketch example by what I mean by that. What we're saying is essentially, let's scroll down here a little bit. So if we've got a graph here of a parabola, so here's the xy coordinate plane, here's the y-axis, here's the x-axis. If we graph a parabola like this, we know that the vertex occurs right here. It's this red point. What's really convenient about this is that whatever this value is down here, like let's say it was 7, then the x value would be 7 of the vertex right there. And you would actually plug in 7 right here. And then the y value is the same idea. We know that the y value is that k number, whatever the y value happens to be here. If it was 10, then you would put 10 right here. Okay, so that's what's really nice about vertex form. Okay, what's nice about standard form is, first of all, and I mentioned this earlier, this is typically how we write functions. So this is typically how we write functions. So if you see a function out in the wild, this is probably what it's going to look like. This is a little bit of work, but the vertex is located at an x value of -b over 2a. So if you happen to know the a and the b value, then if you take -b over 2a, that will give you the vertex. Now, just a quick sketch here of a graph. So if you have a parabola like this that you've graphed, and you know that the vertex is right here of a parabola, the way that you could find this x value here is that x value right there is -b over 2a. That's what we're saying. Okay, it's a little complicated, it's a little tricky, but that works, so that's nice. Once you know the x value, you can just plug in the x value to get the y value there, and then you know where the vertex is. Another really nice thing about this form is that you know the y-intercept is at 0, c. So we plug in x, we plug in 0 for x, and then the y value gives us 0 comma c. So I'm going to actually erase this graph right here and then draw another graph for you. Okay, so if we have the xy coordinate plane, and let's say we have a parabola going like this. So we know if the vertex is right here, that when we drop this down here, that x value right there is negative b over 2a. And we know that vertex, or sorry, not the vertex, the y-intercept right there is at 0 comma c. So the y value there is going to be c, whatever the c number is up here. So that's pretty nice. And the last thing I'll say about this is that it's actually, in my opinion, fairly easy to find y values and graph. So what I mean by that is if you wanted to see what this graph looks like generally I have a hard time knowing what a quadratic is going to look like when I just get it in standard form. But if you make an xy table, right, if you come up here and you make an xy table and you want to plug in -2 for x, it's fairly straightforward. You just plug in -2 and you square it, and then you plug in -2 here, and then you can figure out the y value. It's a lot of work, but it's fairly easy work to do, in my opinion. Okay, so that's standard form. Okay, and so the last one I want to talk about was factored form, and factored form is really great for finding the x-intercepts. And what we mean by that is when you graph a quadratic, so we'll just sketch an example of one here. Not the best, but it'll do. So we've said that the vertex is up there at that green point. Now what's interesting here is that when you have a function in this form right here, the p and the q numbers happen to be the x-intercepts because of what we said earlier. So those values right there, hopefully you saw me put them in here, that's the p value right there, the pink one, and then this teal one right here is the q value. And the a value is still the same as the a value from the other forms, from like standard form and vertex form. So I really like factored form when I get it because it instantly tells me what the x-intercepts are. Now, when you know what the x-intercepts are, so once you know the x-intercepts, you can find the vertex. And I'm going to write something down here that's going to look awfully complicated, but I want to explain it to you first. If parabolas are symmetric, which we've said that all parabolas are symmetric, that means that if we draw a line right here, I'll just do it for a second, and then we'll erase it. But if we draw a line right here that goes right through the middle, the parabola over here and the parabola over here, they're going to be mirror images of each other based off of this line. Now, I didn't draw it the best, but bear with me here. Okay, so what I'm saying here is that this red line here, which we call the axis of symmetry, is going to be the same distance from the purple point as it is from the teal point. So the question is, how do you, if you know a point here and you know a point here, how do you find the number that's exactly halfway in between them? You just take the average of those 2 points. So if you think about this, the x value of the vertex, so if I wanted to know this number right here, wherever this crosses, the x value of the vertex technically is going to be p plus q divided by 2. That's how you find the average. Okay, once you know the x value, you can plug the x value in here. Like, let's say this x value was 4. You would just plug in 4 minus, and we already know what p is, let's say it's like 2, and then you would do 4 minus q, which in this case would be 6, and then you can find, assuming you know the a value, you can find the vertex really quickly and easily. Okay? You can find the y value of the vertex, and then you can plot the vertex, and then once you know the vertex and you know the x-intercepts, you can start to sketch a graph of the parabola. And again, just like on standard form, I think it's easy, fairly easy, to find the y values in the graph if you wanted to make a table, like an xy table.